Hello everyone, welcome back to the web propagation modeling in ABAQUS in steel wire. So today we are going to, we will try how we can generate the flexural wave. So I am going to use the previous model so that I don't have to actually build everything from the scratch. If you want to see how I developed this model, you can actually go back to my previous videos, so you will understand. This is a repeating task. I don't want to repeat it right now. So what I can do, let me copy this model and let's make this model name as Flexural. Okay. So if I click on it, so okay, I have everything here. It's just a previous one that we did. Everything is similar. Okay. And let's see if we have to modify something. This one looks good, right? This is the style, yeah, and the illustrative properties, yeah, okay. So the next, the assembly, that also looks good. The step time. So yeah, that is 0.001. Okay. That also good. If I go more details in the step time, this is the step time increment. And this is the field output that we're looking for. And everything is already there, so I don't have to do actually anything. There's only one thing that I have to do is to apply the load. So while we were generating the longitudinal mode, we were applying the our tone burst or the load on this surface. So the longitudinal or in the axis of the pipe. Okay, but since we want to generate the shear mode or the flexural mode, which is something like this way to travel, so we have to apply some force perpendicular to its longitudinal axis. So we have to actually apply some force in the y directions. So in order to do that, we need to create some partitions, and we need to select some area on this surface so that we can select that area and we can apply the load. So this is the difference. The main difference is that in the longitudinal mode, you apply the load in its axis or its longitudinal direction, and in the flexural mode, you apply the load perpendicular to its axis. Okay, longitudinal axis. Okay. So to do that, let's go to the part. And again, let's create a data point XY, and I want to choose a very tiny region, not all. Okay, so let's make it 0.998. See, okay, done. Let's do the partitioning. Choose this guy. Okay, there is one thing. Before partitioning, there is something else you have to do. So I want to do partitioning the whole guy also. Okay, so I want to choose this guy. Done. Yeah, I would like to delete the previous meshes. Let's see, if I choose this view, I want to go 0.8. Okay, so and then let's do these things again. Choose this guy. Click done. This is 0.2. Okay, done. Now let's choose the other face. Do the same thing. Choose this guy. Done. Partition. Choose this guy. Done. create rotation. So it's up to you how much area you would like to select on the surface. I am just choosing the 2%, sorry, 20% of this whole region, something like that. Yeah, right. Yeah, 20%. Okay. So now let's partition it using this one, and I want to partition the whole guy. Okay, done. Choose 3 points. Okay. No, so there's another thing. Before doing that, I have to partition the other face also. I mean, I didn't do it in the bottom side. So let's do this again. Let this guy done. This time we're going to yes. Select this guy. Done. Okay. Choose the other surface. Select this guy. Done. So select this guy. Done. Now, now do this partition. Choose 3 points. So this is the node, first node. This is the second node. Let's see how this partition looks like. Okay. So the other surface. Yeah. Okay. Now again. Okay. So I will tell you why I am doing this partitioning. Let me finish it first because since it's not this one. Okay. Choose like this. I think I created a node here, but it's not showing. Okay. Let me I'll save this. Let me go to this one again. Let's do this one. Sorry, it's showing. This point is not showing. Okay, now let's do this. Um, this one, this one. See how it's looking like this time. Okay, so the reason I'm doing this kind of partitioning, as I mentioned, so I would like to actually apply the load on this surface. So why I'm doing partitioning on these both sides compared to the centroidal line. So let's say if you apply the load on this surface only, then the load is not symmetric to the whole board. You see the load is acting most of the load is acting on these sides rather than these sides. So if you want to make the load, if you want to create a proper flexural mode, you need to apply the load as symmetric also. Not only making the mesh symmetry is on one options, you have to be considered, you have to be consistent with the loading conditions also. So for this reason, that's why I am actually creating two surface. Now I will do the partitioning using the data. Okay, so this is my data. Okay, I don't need to hold to the whole. I'll just select this one. This one. Done. Yeah. So I have these two surfaces, right? And now I can apply load on these 2 points. Okay. So I'm done with the partitioning. Now let's go to the load. So I already have a load, if you can recall, but what I'll do, okay. Let me define this create a surface. Okay, so let's go here. Let's go here. Let's create another surface that is, let's say it is front and top. So choose these two surfaces. While selecting this two, I am using Shift button from my keyboard. Okay, maybe that will help you. And now, okay. Yeah. So this is my load right now. You see, I can go on this region actually. So they are now symmetric. So everything is similar. You don't have to do something differently. There's another thing I'd like to show you. So the this speed was for the longitudinal mode, if you can recall from my previous video. But for the flexural mode in still, I believe the speed is close to 3000, let's say 150, something close to this. I forgot the example, but something like this. So if you plug this value here, you will get this value much higher. Okay, greater than I mean 0.0008 right now, but you will get something 0.001 or 0.002, something like that. However, I'm not going to change the time period in my step because I will prepare a separate video on how you will select this is time period in your step, and also the time increment in the step. Okay, these are something else to discuss, but right now let's use as I am using right now. Okay, so everything is okay. Now let's go to the mesh. Since I created some partitioning, I did some partition, previous mesh has been deleted. Now I have to select the, okay, sorry, select the part, mesh, and I'm using 0.001. Actually, let me try increasing the mesh size this time. Let's see what happens. I'm using 2mm mesh size, okay? Okay, now see my mesh looks symmetric. Yeah, it looks symmetric, but I am not happy with it. So what I'm going to do, hmm, I'm going to decrease my mesh size. I think that's the best way. Yes. Okay. Okay, let's see this time. Yeah, so you see my mesh looks symmetric. If I look on the other side, they are symmetric. Okay, so you need to make your mesh symmetric, and also you need to apply symmetric load to get proper wave propagation while you're modeling in the ABAQUS. These are the two things I can say right now. The next thing is I need to assign the element. Done. Yeah, I'm using this as default. There is something, I'm not going to discuss that part right now. Okay, now let's go to the job, create a job, job 2, job 2 here, continue. As I mentioned, I already found the processor. Okay. Here. So, right, back. Okay. Submit it. So let's running. Let's see how much time it takes. We will meet a couple of minutes later. Hello everyone. So the analysis has been finished. Let's look at the results for the flexural mode. Okay. So this is the contours one. I'd like to see with only the feature edges. And also I'd like to increase the scale factor so that I can see how the waves is traveling. Okay. Yeah, and choose the color bands, spectrum, reverse range. Okay. 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 So yeah, you see the wave flexural mode where it's traveling. So if I zoom in, then you will see. Okay. Maybe if I into the external edges, then you will be able to see it better. And you see the flexural wave is traveling. So this is the way you can generate the flexural mode. And if it's symmetric, I mean, if your mesh is symmetric, your load is symmetric, then it will actually reflect back, and your bar will remain as it was before. Okay. To me, you see, this is the flexural mode. Okay, so the next thing is that let me see with the different viewports. So let's see. Okay, for zoom viewport mode. This is that. Okay, and try the vertically. And for this guy, I don't want to see all things. Let me remove everything. I just want to see that. Okay. And maybe since reverse or invoice giving me much difficult to visualize. Okay. And here let's choose the feature edge. Okay. Let's do this guy. So here, result. First of all, this one. We go to our result, history output. Let's choose the A2. And I want to see the font. And here I want to see in the middle. Here I want to see at the end. Okay. Okay. So let's see how it's look like. Oh, okay. I have to link them actually. So link the reports. They're linked. Let's run them. So you see the way it's traveling, and at the front you saw a larger spikes, and it's traveling. It reached in the midpoint. You can see the signal in the mid. It's traveling and it's going to the end. So and then it's coming back. Here is one thing you will see as differentiated with compared to the longitudinal mode is that we use the time period same, I mean 0.001 second. But let's look at this end node. We are seeing only one spike. I mean, the wave is not reaching at that point. That's why we're not seeing it. So the reason is that actually, I mentioned earlier, the speed of the flexural mode is much more smaller than the longitudinal mode. So that's why its travel period or travel time is higher, and so that's why we are seeing only one signal at the end node. Anyway, so now let's link them. Okay, let's go to my XY. I want to see only the A3 right now, and let's click save this one as save as. No, okay. Let's put the prompt, save as. Okay. Let's put the in, save as. Now let's put the plugin tools, utilities. So I want to save this guy. Okay. So it will take some time. Okay. I will join once this data is exported to the Excel file. So the data has been processed to the Excel file. Now this time we will actually calculate the speed. Let's see. So and using the same MATLAB code. This was in the middle, and some was in the end. So this distance is 0.5 meter. So I am using this distance to calculate the speed. Okay. This is my graph. So I'm taking it a bit to. So here this the initial some of the noise. So I'm considering these as my first arrival. And here this as my first arrival. Sorry. So you see the speed is 2,964.5. And if I want to calculate the theoretical speed, 9.3. So you can see the theoretical fraction of 3,130.4%. So they are almost close enough But again, there is a difference, and that difference is due to the dispersion. That's I don't want to discuss right now. So thank you so much for watching these tutorials. In the next videos, we will show you how you can generate the torsion. Thank you.